It might surprise you a bit to find out that behind the MVC view is, by default, the same engine used by ASP.NET Web Forms. Appropriately enough, this engine is called the Web Forms View Engine. This engine is built on the Web Form View Engine class, which provides many of the most useful ASP.NET features, including master pages, server controls, some types of caching, design tools in Visual Studio, and lots more. As a result of sharing the View Engine with Web Forms, you build MVC views that look an awful lot like Web Form pages. They use the same syntax for code nuggets that embed code, the page directives, and even server controls if you care to use them, although generally you shouldn't within an MVC application. But a view doesn't use many of the features implemented in the system.web.ui.page class. That's the class on which web form pages are built, including things like events, the page lifecycle, view state, and other web form features. Instead, a view derives from system.web.mvc view page, which gives a view its features that are unique to an MVC application. Now, interestingly enough, view page itself inherits from page. So if you really want or need to use some of the web form features that are implemented by the page class, you can do so. But those features aren't likely to behave as you'd expect, and bridging the web forms and MVC technologies is not likely to be a very satisfying solution. Now, creating views can be a little bit confusing if you're used to web forms. But as long as you remember that there's no code behind file or page events, you should be able to keep everything clear. Remember, too, that the only interaction with the rest of the application is through a controller. And all the controller really does is pass the view some data in the form of a model and other view data key-value pairs. So let's look at the anatomy of a request coming into an MVC application. So that shows how the overall request goes from the request to the controller, which interacts with the model, which may or may not interact with some sort of back-end persistent storage, returns information to the controller, which then selects a view and produces a response to the user. So in order to handle a user request, the controller is going to interact with the model in whatever way is necessary to respond to the request. The controller then selects a view and passes it whatever data the view requires to generate the page. The view engine then reads the view template and dynamically generates the HTML that is sent to the user. So in this section, you're going to learn about some of the many features that you can use to build views that provide a robust user interface for applications. The MVC framework has a rich infrastructure for creating responsive and attractive websites for your users. The ASP.NET Web Forms View Engine is the default view engine for new MVC applications, as I mentioned. But, like many other features in the MVC framework, you can plug in any view engine you want, or even write your own using the same features in the .NET framework, on which Microsoft built the default Web Form View Engine class. With a different view engine, you can use a completely different syntax for defining your views, instead of the standard ASP.NET syntax. For example, you could use XML templates and XSLT to transform them into HTML. There are several open-source alternative view engines available, including things like Spark, NVelocity, Braille, and NHAML. Most of the time, though, you're probably better off sticking with the default Web Forms view engine, mostly because it's familiar, and it also works pretty well after maturing for some 10 or 10 plus years. And it's also the default, so it's just flat out the easiest to use. You don't have to do any additional configuration to use that view engine. Now, creating a view template in an MVC application is not all that different from creating a dynamic HTML page using web forms. The main difference is how you use data from a model and code in the view to generate the page sent to the client browser. What we're going to do now is talk about how to create a view and add content to it in various ways. ASP.NET MVC2 in Visual Studio 2010, or if you install it to use with Visual Studio 2008, adds numerous tools to the development environment that simplify creating new MVC views. Most commonly, you'll create a view from a controller action method, but you can also create a new view manually in Solution Explorer. So let's explore some of these options. By far and away, the easiest way to create a new view is from an existing action method in a controller. So if I go over here and open up a controller, I'll open up the home controller, and right-click within this method, I can select Add View. So here you can create a partial view, which is essentially a user control. You can create a strongly typed view based on some data model that you have within the application. And then you can also have MVC provide the data scaffolding by selecting View Content. And then you have the option of using a particular master page. The benefit of creating a view from an action method like this is that the dialog box fills in some of the options for you, but more importantly, it places the new ASPX file in the controller's views within the project folder structure. So that's one way of creating a view. You can also come over here and go down into the Views section of the application. Let's go down here into Home, and right-click here and select Add and View, and you get the same dialog box. The difference here is that the view name is not automatically populated with the name of the action method. That's not exactly a big downside. But you also have to make sure that you create the correct kind of view in the correct location, because if I accidentally create an account view here within the Home folder, then MVC is never going to find that view unless I explicitly provide it with the path to that view. So it really makes it easier if you stick to creating a view from an action method. Now the one exception here is if you're going to create a view that is going to be shared by more than one controller. Then you want to put it within this shared folder, in which case it's really easiest to right-click, Add, and View, and then do whatever you need to do to create that view. The benefit is that after MVC searches the controllers section of the Views project structure, it'll look in the shared folder for a view of the appropriate name. But as a practical matter, because views almost always are tightly bound to a controller, you're rarely going to share views across controllers. More commonly, you'll share partial views across controllers, which are user controls, and we'll talk about that a little bit later. Now yet another option is that you can create a view outside of this Views folder structure. So let's say, for example, I wanted to create a view here in the Models folder for whatever reason. One downside here is that because I'm outside of the Views folder, I don't have that view selection here. But I can select New Item in order to come in and open up the Add New Item dialog box. And then I can select Web or MVC2 and create a View Content page here. And I can give it whatever name I want and so forth. So I'll go ahead and create that. I have the option of selecting a master page. And now we end up with this new view within the Models folder. Definitely not something you should generally do. But notice that you get no benefit of doing it this way. You just get the empty content for a page that uses a master page. So you'll have to do all of the work of implementing the view. You'll need to always provide a path to this view anytime you use it from within a controller. And you'll have to keep that path updated if you move the file within the project. It's just creating a whole lot of extra work for yourself. The tools in Visual Studio are designed to help you observe convention over configuration. And one example of that is by placing new code files in the conventional location. You can almost always override those locations, but the significantly increased work that results is virtually never worth it, and your code is going to be less maintainable. So until you know MVC well, and only when you have a very good reason to violate the convention, you'd be well advised to not fight Visual Studio and put things in the places where it expects. At its heart, ASP.NET is a framework for building dynamic web pages and delivering them to users. The user gets a page consisting of HTML, and maybe some other web standard content such as CSS and JavaScript. You can include static HTML in the Views ASPX file and provide dynamic content either using client-side JavaScript and maybe Flash, Silverlight, whatever, or server-side code. What we're going to do now is focus on using server-side code to provide dynamic content. And there's a variety of ways to provide a combination of static and dynamic content to a view. And here you'll learn about some of the most common ways to add that content. All of the static, unchanging content that you're going to put into a web page that's created from a view should be included as static HTML within the view definition. This is going to result in the best performance for a page, since the application isn't going to need to do any view processing on the server. So here's an example of a static action method, and it's contained within the content controller. This is just about the simplest way to invoke a view. The view itself is named the same as the action method, and the static view is located in the controller's views folder. So as a result of following all those conventions, all the code needs to do is call that view method. So let's take a look at that view. I'll come down into the content and static to open up that view. And as you can see, there's just static HTML, a whole bunch of text. There's no code nuggets, there's no anything dynamic going on here whatsoever, other than the fact that the page is a content page for a master page. And so it's going to need to do a little bit of combining with the master page and inserting the content. But otherwise, it's all static text. So the page could be a little bit simpler if you didn't care to use a master page, but I'm going to assume that we're planning to use MVC for a real application, rather than just displaying a small amount of text in a browser window. I'll go ahead and run the application. Switch back over to the controller there. And I'll click on the static content. And there's the result. Nothing very exciting, but it does show that you can easily build static pages into an MVC website. Most sites have at least a few static pages, maybe even just for about content, whatever. And so MVC accommodates those kinds of static pages very easily. At the other extreme from a view that consists entirely of static content, you can also use a content result object to entirely define the content of a web page within an action method. Now, strictly speaking, this isn't a feature of MVC views, since there's really no view involved in this technique. But when you need to create a web page that has to be entirely dynamic, this is a good option. A content result has three properties. Content takes the content that you want to display in the form of a string. Then content encoding defines the encoding of the content. And content type tells the browser what the content consists of so that it can render it correctly to the user. Some common settings for the content type include text plain for just plain text, text XML, and application JSON. But there are many others that are defined by the World Wide Web Consortium. So let's take a look at how you can use this content result. Let's say that you have some XML data in a file on a server that you want to send to the browser as XML and let the browser deal with displaying it. One way to do this is to read the data from the file in an action method and use a content result to send it to the browser. And that's what this read Hamlet action method does. So it uses fairly standard system.io code in order to create a string file name with the path to that file. So as you can see, it's located within the content directory, which is where, for the most part, you should put any kind of content, any kind of data that is input into the application. So as you can see, I have an XML file as well as a DTD file that describes the structure of that data. Then use a stream reader to get a stream of that data and puts it in a text reader, and then populates this content string with the full contents of the file by calling the read to end method here. And there's lots of different ways of doing this. And then the action result finishes up by using the content helper method to pass in the contents of the file and tell the browser that it's XML data. So I'll go ahead and run the application. Remember, there's no view involved in this because we're generating the data that's going to go directly to the browser. So I'll click on the Hamlet as XML link. Now the hamlet.xml file is about 300K, so depending on the speed of your machine, it's likely that it's going to take a few minutes to load into the browser window. And here's the result. So we have this displayed as XML. It's actually still loading. It takes a while for the browser to fully parse that file. But we can collapse and expand different sections, and this has the entire set of code for Hamlet. Now the important thing to understand about using content result is that you define the entire contents of what the web page is going to display. Alternatively, you can provide data for updating a portion of the page, such as when the page makes an AJAX request for JSON data. So that's a scenario where content result is also useful. One of the easiest ways to populate the view with data, and probably one that you'll use often in your MVC applications, is to use a view data model along with name-value pairs. The controller's action method is responsible for providing the data to the view before invoking it. And then to read and display the data in the view, you can use inline code using the ASP.NET angle bracket % delimiters for code nuggets. You can then use a code nugget to evaluate results and include simple user interface-based logic within a view. Now, if you have experience with ASP.NET Web Forms, it may just seem wrong to use code nuggets like this. A web form is a hierarchy of server controls, and using inline code is a bit of an aberration that harkens back to the spaghetti code of classic ASP and server-side VB script. But think of a view as a template for a web page, a bunch of text that the browser is going to use to display a web page to a user. As long as the code nuggets are strictly limited to user interface logic, you're adhering to the principle of separation of concerns to keep your code clean, simple, and maintainable. A well-designed and implemented MVC application can optimize application efficiency and maintainability. Say you have a person class in your application defined like this. You have an ID and a name, an email, phone, birth date, and a list of strings that might contain the list of dogs that the person owns. So this is going to be the model for a particular view within the application. And then over here within the content controller, you can have this getPersonAction method. This initializes a person object that news up a person and sets the various properties for that instance of the object model. The code is then going to pass that person object to the view method, which assigns that object to the model property of the view data object. The code also creates an updated variable that contains the current date and time. So this code is using both facets of view data, the view data dictionary that contains, as well as the value of the model property. Because by passing it to the view, MVC will assign that person object to the model property of view data. And that makes both of these sets of data available to the view. So it's really important to understand that all of the data, model and updated value, is going to pass from the controller to the view using the view data object. So let's take a look at the view. The view is bound to this person object. And then you can use that object through this model object in order to read the data, including the email, phone, birth date, and so forth. You can even have a for each loop in order to loop through that list of strings and present each of the dog names in a list item. So this code uses the model. This is the model that the view is bound to. And then you can use that updated variable within the viewData object. Remember, it contains essentially a dictionary object. Cast it to a date time. And in this case, I want the view to display just the short time string. Now, there are a lot of different ways that you can do this. Obviously, within a code nugget, I could just use the datetime object, get the current date and time, and then format it however I want. Alternatively, I could also, within the controller, within the action method, convert that time to a string and just pass the string to the view. So there's lots of different ways to do this. But the important point is that you always want the view to format the data. So in general, give the view the raw data and then let it format it, display it to the user in whatever way makes sense for that particular page. All right, I'll go ahead and run the application. And I'll click on the Get Person Info. And there you can see the page where it has read the data from the model and populated this, including the loop that listed all of those dogs, and then also read the updated value from the viewData object in order to display the current time. As you work with MVC and inline code, it might be confusing about which form of a code nugget that you should use. There are lots of options: angle percent, angle percent equal, angle percent colons. In general, you should use the versions with either the equal or the colon when the method you call in the code nugget returns a string. And you should always prefer the colon version over the equal sign as of MVC2, because the former automatically HTML encodes the string to reduce the risk of cross-site scripting attacks. The nice thing is that ASP.NET and MVC is smart enough not to double encode strings that are already encoded. Now you should use the angle bracket percent format when the method you call inserts data directly into the response stream for the view. But the problem is, it isn't always obvious what methods return strings and which write to the stream. So it's a matter of looking at the return type of the method that you're calling. So maybe by a documentation or a little bit of trial and error. So let's talk a little bit more about viewData. ViewData is actually a property of the base ViewPage object from which an MVC page derives. The property returns a ViewData dictionary object. It functions as a data conduit between the controller and the view. And it has two ways of passing data. The first is as a dictionary. This lets you assign name-value pairs to the ViewData dictionary, like the updated value that you just saw. Then you can read the value in the view, casting it as necessary for display to the user. The name is a string and the value is an object. The other way is using a strongly typed model. In this case, you assign a single object to the ViewData's model property, which lets you access the object as its own type without needing to cast the object before you can use it. In the view, you use the model property of the view page, which returns the object stored in the ViewData within the controller. And as you just saw, you can combine these two uses of ViewData however you wish in any action method, which gives you lots of flexibility in how you pass data from the controller to the view. You can even pass additional objects that sort of function as additional models for the view using the dictionary portion of ViewData. Now, how you use the model in the view depends on whether you create a strongly typed view or a loosely typed view. And you define that using page directives. The nice thing is that the page directive is set up for you if you use the Add View dialog box in order to create the view, depending again on whether you opt to create a strongly or loosely typed view. The controller itself doesn't know or care whether the view is strongly or loosely typed.